Welcome back, student. This is lecture number 4 for the course name Structural Dynamics. My name is Mohammad Zain, Assistant Professor, Faculty of Civil Engineering, Sri Ramsur Memorial University. Today's topic name is 2 degree of freedom system. In today's lecture, we will covering about introduction to 2 degree of freedom system, concept of shear building, assumption in ideal shear building, free vibration of undamped 2 degree of freedom system, free vibration of damped 2 degree of freedom system. Okay. Now in introduction, okay. Hmm. See what is happening here. Previously we were dealing with the 1 degree of freedom system, in which only one coordinate was necessary. Okay. Now uh, in this lecture we are dealing with 2 degree of freedom system. So therefore two independent coordinate is necessary to describe the motion completely. Okay. For an instance, for single story building will be your single degree of freedom system, and it means in today's lecture we are going for a two story building, a two-story building for the analysis or governing equation of free body diagram. We will be dealing with the two-story building. It is written here. In general, a system requires a number of independent coordinate to describe its motion is called multi-degree of freedom system. Means if a system is having 3 degree, 4 degree, 5 degree or n number, it will be called multi. So 2 degree of freedom system is a special case of multi-degree of freedom system. Now concept of shear building. See what is it in here? A shear building is defined as a structure in which no rotation of a horizontal member at the floor level, since all the horizontal member are restrained against rotation, the structure behave like a cantilever beam which is deflected only by shear force. See what is happening. Let's consider this to be a structure. Okay, this is a structure, and this is my hand is the foundation. Okay, now this is foundation. Now structure is here. Now this structure is behaving like a cantilever beam. See, I am rotating. So this is the foundation. See, now it is a cantilever beam. Okay, it is behaving just like a cantilever beam. So this is the concept of the shear building. That in this the building, see, whole building act as a cantilever beam. Okay, for example, this is many level of stories are here building, and this is the foundation. Now it will be considered it as a cantilever beam. Okay, now this is the concept of shear bu- building. Okay, moving on to our assumption made in ideal shear building. Okay, now the first assumption which has been made here, the total mass of the structure is concentrated at floor levels instead of distributed mass. Now what this is very important assumption, as is it is making our in as it is making our structure degree of freedom, which is having infinite degree of freedom, to a finite number of degree of freedom, as it is considering lumped masses at the floor level. Now the second assumption is that the horizontal members on the floor are infinitely rigid as compared to the column. It means that all the flexibility or the stiffness is only provided by the columns. Your beam or the slab is being considered as a rigid or infinitely rigid member. Okay. Now the third assumption, the formation of structure is not affected by the axial force in the column. Okay. Now, fourth assumption is that stiffness due to column and inertia due to slabs are only considered. See, we are considering lumped mass at the slab level only. Okay, so stiffness will be provided by the columns only, and inertia will be acting at the slab level only. Okay, no joint rotation is considered, or no joint rotation in the structure. So actually we are building our structure monolithically. Monolithically means same section at each floor, so there are very less chances of joint rotation, and we are but there might be some chances, but we are considering here no joint rotation in the structure. Now the final assumption: load act horizontally so that the slabs move parallel to each other. See, now this assumption is also saying that this is a building and this is the floor which is considered to be a lumped masses. In this, these both floor displacement will move parallel to each other only. No other movement is allowed. Okay, moving ne- moving to our next slide. Okay, now see, free vibration of undamped 2 degree of freedom system. What is happening here? We have made a building here, two-story building, and your lumped masses m1 and m2 here, which has been displaced by m1 displaced by x1 and m2 displaced by x2, and these are the stiffness. Okay, k1 and k2. Okay, same here, k1 and k2. So a spring mass system has been formed, that is mathematical or mathematical model has been formed in which these are the columns and these are the slab or lumped masses at the floor level. Okay, this is for first floor and this is for second floor. Now a free body diagram has been made here. Okay, now what is happening here? See, mm, this is due to inertia, that is force equals to mass into acceleration, and this is due to the spring, or you can say by column, and this is k1 x1. Okay, and now see, if the let me clear. Okay, now what is happening? It is moving by x2 and this one is moving by x1. See the concept here, which one will be greater, x1 or x2? See, let me, this is a building, this is a building here. Okay, it has been, if it has been displaced by x1, then it is already displaced x1, so now the x2 will always be more. Okay, see, let me give you an example again. See, in the case of cantilever, we are applying a load, it will get deflected here. See, here the deflection will be more and here the deflection will be less. So this is your, in this case, x2, and this is your x1. So means to say this x1 will always be less than x2. Okay, clear. So therefore k2 equals to x2 minus x1 here, and this is moving here and it is applying the force in the opposite direction. Okay, the as x2 has is greater, so due to this spring, due to this spring, it is making this lumped mass moved in this direction. So therefore k2 is equal, means to say k2 multiplied by x2 minus x1. Okay, now for the second story building, see, this is again due to inertial force, and this is due to the spring const force, or spring, due to spring stiffness force. Okay, now here will be k2 into x2 minus x1. Now what is happening? This body is moving in this direction. Now this spring is making this body to come to its equilibrium position back here, so the direction will be in this direction only. Okay, okay. Now we are going to make a, you can say, uh, equation, governing equation for this mx double dot, this one, plus k1 x1, this one, minus k2 x2 minus x1. Okay, this is equals to 0. This is your equation number 1 for this section. Okay, equation number 1. Now for equation 2, see, This is M1. Okay. Now this one M2 x2 double dot plus k2 multiply by x2 minus x1 is equals to 0. Now this is your equation number 2. So these both are the governing equation of this 2 degree undamped 2 degree of freedom system. Now from these equation you can make a matrix equation also. From that we can solve the or we can analyze this two-story building. Okay. Okay. Now we are here considering free vibration for damped 2 degree of freedom system. Okay, a damping element has been introduced in the first story and the second story of the building. Okay, now I'm writing, see, this is the free body diagram. What is happening? It is just similar to the previous case, only just due to the introduction of the damping element, it is having some of the other element also, like this is due to the damping force has been created in the opposite motion, and this is also due to the damping, due to the second damping, and same opposite force are there. Okay, now I am writing here the uh, governing equation for 2 degree or damped 2 degree of freedom system. Okay, m1 x1 double dot, okay, plus k1 x1 plus c1 x1 dot minus, see, this is in the opposite direction, therefore k2 x2 minus x1, okay, plus, sorry, plus minus minus c2 x2 dot minus x1. Okay, this is equals to 0, and this is your equation number 1. Okay, for equation number 2, m2 x2 double dot plus k2 x2 minus x1 plus c2 x2 dot minus x1 dot. This is equals to 0. Now this is equation number and this is equation number 2. So these two equation are the governing equation. Okay, now when we will solve these two equation, we will be getting our analysis. Okay, so this is how we analyze our 2 degree of freedom system. Like this you can make a mathematical model for n degree of freedom system, and you can make the mass stiffness matrix for n number of degree of freedom system also. Okay, now okay, thank you for attending. This closes our course structural dynamics. Now if you are having any confusion, you can meet me in person also. Okay, thank you very much for attending today's lecture. Again we will meeting with some different course.